Today, we're going to learn how to use the standard template library's array type. Hello, I'm James Helfrich. When you want to use an array in C++, you have many options. You can have an array stack variable, an array heap variable. You can have the standard template library's array and the standard template library's vector. This video will demonstrate how to use the standard template library's array.
There are two main ways to create an array, the default constructor and the initializer list constructor. In order to use the standard template library's array, we first have to #include array, and this gives us access to all the functionality associated with the array. Now the full name is std::array, and we have to specify two template variables, the base type, in this case an int, and the number of elements, in this case I'll say 4. This is the default constructor, so that each element will be uninitialized. So I expect to see 4 elements, and they have random values. Now I can also make it bigger, in this case 8, and now it's going to be fixed size of size 8, and once again they're all uninitialized. Now what I could do is create an initializer list, and this will give a default value to each element in the array. Notice how there's 8 elements in the array, but I'm only specifying the first 4, partially filled. So 1, 2, 3, 4 in the default constructor will get called on the balance. The array type does not have an assignment operator function per se, it just uses the default assign that comes with the C++ programming language. To demonstrate this, I'll have two arrays of 5 elements. The first one has a value 10, 20, 30, 40, 50, and the second one has a bunch of 99s associated with it. Now I'll assign source to the destination. Let's move my breakpoint here, and let's run the code. When I run the code, initially source is going to have the value 10, 20, 30, 40, 50, just like I expect. Destination has not yet been executed. So when I step over that line of code, now destination's filled with 99s. Now when I assign source to destination, we'll see all the values. There are a collection of different operations associated with the iterator. The usual begin to end. We also have the reverse begin to reverse end. In each case, end is going to be the first element off the end of the array. We also have the plus equals and the minus equals. We can jump by a certain amount. We can add or subtract a vector. And we can also take two iterators and we can find the difference between them. And that's the distance between two elements in the array. To demonstrate how this works, I have an array of 10 elements. The first 9 are filled and the last spot is filled with 0. Now I'm going to declare an iterator, and the full name is std::array, the base type as well as the number of elements, : iterator. In this case, I'll assign it to the begin element, which would be element number 11. Now I can also find the value of an element by saying *it, and this will dereference that element. Let's take a look at what happens. When I run the code, then my array is filled with the values as I expect. And then my iterator is referring to element number 11. And when I expand on it, we'll see that it's a pointer to that element in the array. Then when I execute this single line of code, I'm going to get the value from it, and I'm going to stick it into value, which is 11. The declaration for this iterator is really long. Fortunately, since C++17, we have the auto keyword. And since a.begin is going to return an array iterator, then the compiler knows exactly what that data type is, and I can just use auto. Now I can not only retrieve the value with an iterator, I can also change the value with the dereference operator. Let's take a look at this. Now the beginning element initially is 11, but when I step over it, it becomes 9999. Isn't that cool? There's so many other things I can do with an iterator. For an example, I can add a fixed amount to my iterator. Initially I'm at slot 0, now I could be at slot 4. And then I can take auto it is a begin, which is going to refer to 11, and I can find the difference between my new it and my it begin, which would be 4 slots. Now when I run the code, we'll see that it initially refers to slot 11. When I step over, now it's going to advance 4 slots, and it's going to refer to index 4, which is value 55. When I advance begin, it begin is going to refer to the beginning element, and what's the difference between the beginning element and it is 4. There are several different ways to access elements in the array. We can use the square bracket operator, the @at method, the front, and the back. Let's take a look at how each one of these works. I can access the front element with a.front, and I can access the back element with a.back. I can also access an element in the beginning, in the middle, with the square bracket operator. And I'll say the fourth element is a of 4, and I can use the @operator as well. a.at 5 is the fifth element, starting at 0, of course. So when I run this code, I expect front to be 11, back to be 99, fourth to be 55, and then fifth to be 66. So 10, 11, 99, 55, and of course 66. Now, the cool thing about front and back, square bracket, and at is not only can we access elements, but we can also change elements. So now I'm going to say a.front equals 111, a.back equals 999, a of 3, which has the value 44, will now have 444, and a.at 4 has the value 55, and I'll put 555 in it. So when I run the code, initially my array is going to have 11, 22, 33, and so on. When I hit front, now it becomes 111, back 999, square bracket 444, and then at 555. The size of the array is specified at compile time, which means it cannot grow and it cannot shrink. Therefore, there are no insert methods provided with the array type. Just like we cannot insert elements into an array, we also cannot remove elements from the array. The size of the array remains fixed, specified at compile time. There are 3 status methods provided with the array. Empty, which will return true if there are 0 elements in, which is kind of silly because you specify the number of elements at compile time, and why would you ever create an array that has no elements? Size, which just returns the n parameter. And then max size. And max size and size must always be exactly the same, which is the n template variable. So I'll start with my same array I had before with 9 elements, and I'll say auto empty equals a.empty, and that should return false because there are 9 elements. And I'll say size equals a.size, and this will be 9 because there are 9 elements, and max size is a.max size, and then once again there are 9 elements. Notice empty is a bool, size and max size are both size t, which is unsigned integers. Now since I have 9 elements in it, I expect size and max size to be 9, and empty of course to be false. Let's verify that's true. So initially they're unknown. I have my 9 elements, step over it, empty is false, and then size is 9, and then my max size is 9. Now, right now I've initialized these with 9 values. What if I leave them uninitialized? Then I still have 9 as my template size. I just have empty values in there. So when I run this, we're going to see that my array has uninitialized values, and then when I execute it, empty is still false, and size and max size are still 9 and 9. If I want to get truly 0 size and empty is true, I have to set my template variable to 0 as the size of the array. In this case, when I run it, empty is true, and size and max size are both set to 0.